one of the big issues that pops up with functions is the issue of domain. So let's say the domain of a function. So there's really two key ways to think about domain. One is the domain is just all the allowable input values. Another way to think about domain, though, is for us, we're looking at functions of real numbers. So it's all the numbers you can plug in that don't violate some of the fundamental rules of mathematics. And so what the two rules that we're interested in so far are the following. We want to avoid, let's just say, no division by zero and no even radicals of negative numbers. Can't take an even radical of a negative number. So on the one hand, in general, whether you're talking about functions of real variables or functions of some other set, the domain of a function is all the allowable input value. It's the set of things you can plug into your function. For our specific context here in calculus, we're interested in all the numbers that when you plug them in, you don't divide by zero and you don't take an even radical of a negative. So let me show you what I'm talking about. We want to avoid that situation. You don't want to get a 3 over 0. That would be bad. In this case, there's a serious problem. Whatever you plugged in that led you to this would be bad. Also, if you have a square root of a -2, that's bad, or a fourth root of a -3, that's bad. Any even radical of a negative, you've got to avoid those situations. Okay, so having said that, let's look at some examples. I won't spend a ton of time on this because this should be review for you, but this is really important and we're going to need this as we go along. So let's do the first example. Let's say we'll have f of x equals, let's say, radical x minus 2. And so we say, okay, this is an even radical. So that means whatever's under the radical has to be positive. If we're going to talk about the domain of this function, we have to have x minus 2 greater than or equal to 0, which means x has to be greater than or equal to 2. X is representing the number that you plug into f. So if you're going to plug a number into f, it has to be greater than or equal to 2. You can visualize this on the number line. Here's 2, and we're saying you have to be bigger than or equal to 2. And so I'll put a square bracket there on towards infinity. We're going to use interval notation, so we would say that the domain of f, I'll write it like that, is the set square bracket 2 to infinity, as follows. Okay, so there's one example. Here's another example. Let's consider the function g of x equals 1 over x squared minus 1. And so we realize, oh, there's a fraction here. It's possible I could divide by 0. Let's look where the bottom equals 0, and I get x squared equals 1, so x is plus or minus 1. And even though I solved where is the bottom equal to 0, I'm actually fundamentally interested in those values x that don't make the bottom 0. So in the end, these are the values that I don't want to allow. If I plug these values into my function, then I'm going to get a 0 downstairs. And you can check it. Check out g of 1 is 1 over 1 minus 1 is 1 over 0. That's a problem. It's undefined. And so this, to summarize what we're saying, the domain of g is the set of x such that x is not equal to plus or minus 1. That's one way to write it. If you want to write it on a number line, all you're doing is actually leaving a hole at -1 and a hole at 1, like that. So here's another way to visualize it. If you want to use interval notation, which is what we're going to use, you would say, look, the domain of g, whoops, my pencil acted up there. The domain of g would be the interval minus infinity to minus 1, union minus 1 to 1, union 1 to infinity, so on and so forth. All right, so those are the kinds of things we're going to need to be able to do in this course. So we want to avoid division by 0. We want to avoid even radicals. Maybe let's just do one more quick example. This will be example number 3. Let's consider the function h of x equals 1 over, I don't know, let's say x plus 5. And so now we have 2 issues. We have what's under the radical needing to be positive. We have to have x plus 5 greater than or equal to 0, and we also have to have whatever's downstairs not equal to 0. There's sort of 2 issues to track. Well, the first issue just means x has to be greater than or equal to negative 5. Think about it. The only time a radical is 0 is when the inside is 0. So we can't have x plus 5 equal to 0. Whoops, I did not mean to write a negative there. X plus 5 can't equal 0, so x can't be negative 5. Think about what you're saying. On the one hand, you're saying x has to be greater than or equal to negative 5. On the other hand, you're saying it can't be negative 5. And so the point is the domain of h would be, let's draw it first on the number line. Here's your negative 5. We want everything bigger than negative 5, but not including negative 5. So we would do a curved bracket, negative 5 to infinity. And so we'd write that like this, minus 5 to infinity with a curved bracket. Hopefully you've not forgotten we never include plus or minus infinity, that they're not numbers. They're just symbols representing the concept that there's no end, there's no upper bound here. All right, well, let's stop here. We'll look at just a few more review type things, and then we'll be done with these sections, and you guys can tackle the homework.